Welcome, everyone. Thank you for joining us. My name is Tom Korn, and welcome to the session on transforming security from bolt-on to architected in. Over the coming 45 minutes, I'm going to dive into this notion of how security is fundamentally being transformed through leveraging cloud and mobility. And the central theme of this is going to be about gaining what I term home court advantage. The key idea is that the transformation that happens in security isn't simply that it's being architected in. That's the what. The why is to really create a situation where we can have home court advantage as defenders inside our environment. That's what's so fundamentally transformational about this. Today, we're spending somewhere in the order of about $3.7 trillion on IT worldwide. That's been growing in sort of the low single digits, most recently around 4.5%. By contrast, security spend today is on the order of $91 billion, but growing at twice the rate of IT overall. At 10.2%, it's becoming an increasingly significant portion of IT spend. And in fact, the only thing that's growing faster than security spend is security losses, which are growing on the order of about 26%. Now, it says something that we're in an industry where it is highly strategic. We're spending more and more, and yet we seem to be falling further and further behind. These kinds of figures are indicative not of something that we need to incrementally improve, but fundamentally change how we're doing things. There's no way around it. Our current approach really isn't working, and we need to rethink our approaches in some fundamental ways. Now, the $91 billion is spent on a dizzying array of products, thousands of products from many hundreds of vendors. But actually, the more interesting number on this slide is 50. 50 is the average number of products that an average organization is using to do security. That's an insane figure, right? It means a multitude of products, each with their own version of the truth, each with their own alignment issues. And candidly, this is part of the issue, the vast complexity. In most areas of IT, you're dealing with 4 or 5 products. Here, you're dealing with an order of magnitude more products. Now, all of these products are focused on trying to address the fundamental threat that we face and protect the critical applications and data. Now, there are 3 forces that are making this a very challenging exercise. Now, one, of course, is the threat actors themselves. Nation states, organized crime, hacktivists. These represent the more sophisticated of those groups. But the weaponization of cyberspace, where we have toolkits that we can use in order to essentially build attacks so that a less sophisticated attacker can create much more sophisticated attacks in much higher volume, is one of the factors that's creating an untenable situation as a defender. Another factor is actually just how the environment that we're protecting is fundamentally changing. In our data centers, we're moving very rapidly from physical infrastructure to completely virtualized and cloud environments. We've been contending with virtual compute for some time, but now virtual networking, virtual storage, infrastructure as a service, platforms as a service, all of these things are changing the environments that we protect and the dynamics and the properties of those environments. The same is happening on the user side. Gone are the days where we had corporately owned, managed, and controlled devices for our users. Today, we're increasingly faced with devices our users are using to interface and connect with our applications and data that we neither manage, own, or control. The third factor that's making this is the actual application development itself. That's rapidly moving from a waterfall methodology where we have new versions of applications coming out on an annual basis to a much more agile DevOps approach where applications might be changing every week, every day, every hour. how are we to keep up with a growing array of very sophisticated attacks on a fundamentally changing infrastructure where the thing we're protecting is changing so rapidly as well? Therein lies the challenge. Now, it is often said of security that it is an asymmetric battle. And what that means is that defense is always harder than offense. Right? An attacker can fire 1,000 bullets and only has to succeed once. A defender has to succeed 1,000 times. But as you look, and in this slide, we have a representation of a simplified kill chain, which is a process that an attack goes through. What should be true is that as an attacker moves through this kill chain and goes past infiltration into our environment, it should get increasingly symmetric, meaning the advantage starts to go to the defender. Why? Because of this notion of home court advantage. Once an attacker enters in, now they're in your house. And you know your house and how you use your house, and that gives you an advantage over an attacker that actually has no clue of that. If someone were, for example, to sneak into my house in the middle of the night, they're liable to find an environment where all of the doors are closed, some of them locked. They'll find that the lights are off inside the home. They'll find my teenage son's skateboard precariously hidden somewhere in the hallway, although I'm more apt to find it myself than an attacker. Nonetheless, when I hear sounds in the house coming from the playroom at 2 in the morning or from my garage, or I understand the context to immediately understand that's not right. And so I have the ability to react in ways or to lock certain things that really shrink the attack surface or allow me to respond more intelligently, much faster. This is the nature of a home court advantage that begins because I understand my family and how my family uses the home. Right? I understand what I'm protecting and how what I'm protecting uses the infrastructure itself. Armed with knowing how my family uses the home, the first thing I do is I create a perimeter defense. It could be alarms or locks that locks the outer circles of my home. And then my understanding of how I use my home would allow me to close doors. It might say, you know, in my case, I might lock the indoor entrance to the garage or my indoor entrance to the patio on the outside. Other rooms, like my kitchen or my playroom, I'm not going to lock down. That would create not a very livable home. What I'll do is I'll monitor those environments, and if I know that those environments really shouldn't be used in the middle of the night, and I will respond accordingly. So some of it is about locking it down, some of it is the way I monitor and react, but all of it is predicated on understanding how we use the home in the first place. So we understand how the family uses the home. We use that to shrink the attack surface, shrink the posture. And then we layer on top of it the ability to understand threats. But now I'm doing so from a much smaller attack surface with much better signal to noise and much better context of what it is that I'm trying to detect threats for. Why don't we seem to get this home court advantage? Because clearly all the numbers suggest that we are not. We're throwing away this home court advantage. And the reason is that if you were to look at our environments and our data centers, to use the same metaphor I used before, you would find that all the lights are on, that all the doors are open, that we don't actually consider or understand how the family uses the home. We don't consider the family at all. And as a result, we don't see playrooms and bedrooms and living rooms. We see rooms. Generic rooms, potentially of different sizes and capacities. In fact, we don't even construct a perimeter around our home, the infrastructure used by an application. We look at this, from an IT perspective at a whole different way. We look at things from a city, from roads, and from rooms. Those represent perimeters, networks, and endpoints. And on each of those dimensions, we're placing security controls that are looking for threats. What does a bad person look like? What does bad behavior look like? And that's what I'm focused on doing. There is no home court advantage in this approach. we will never be better at understanding threats than an attacker, because by definition, an attacker is creating the threats. The best we can do is to try not to be so behind an attacker in understanding these threats. We will never be better at understanding the generic rooms, right? Even in this environment, focused on understanding threats at this generic infrastructure level, when we try to approach shrinking our attack posture, we still take a very infrastructure-centric approach. We segment or compartmentalize all our web servers, all our app servers, all our database servers. We implement security policies like, hey, let's make sure web servers never talk to a storage server, because that would make no sense, or that an app server should only talk to a database server over a certain port and protocol. Now, at the end of the day, this is largely security theater, because it's the equivalent of grouping all the kitchens in the city and grouping all the bathrooms in the city and all the bedrooms in the city. And it constructs an environment for which, if an attacker breaks into somebody's kitchen, they have a wormhole that can instantly transport them to any other kitchen in the city. And of course, once they're in someone's kitchen, there has to be freedom of access to move throughout that house. So what really have we solved? This is the essence of the problem. We're taking these thousands of products, $91 billion of products, we're installing them on infrastructure, generically, machines, endpoints, network links. They're agents on machines or they're boxes on wires. We're first and foremost focused on using these to identify threats coming into that environment. And then we're doing the best we can based on this infrastructure view to improve our posture and shrink our attack surface. It's entirely backwards. There's a very interesting report that came out a little while back written by Neil McDonald at Gartner. Neil developed this framework called the Cloud Workload Protection Framework, in which he stack ranked all the different types of security controls and policies and activities that you could do on a workload in order of how much risk does it really get rid of. The bottom of the pyramid represents things that get rid of large amounts of risk. The top of the pyramid represents things that gets rid of marginal risk. And what are the kinds of things at the bottom of that pyramid? Well, it's things like patching and hardening. It's things like segmentation, application control, system integrity, memory protection. It's things like encryption. The things at the very, very top of this pyramid might be things like antivirus. Antivirus running on a workload, it adds value, but the amount of risk that it really gets rid of from a residual risk standpoint is actually relatively marginal compared to the things that are at the bottom of this pyramid. In fact, 2/3 of the type of things that you would do on a workload that really get 2/3 of the risk are really represented by things that are more to do with cyber hygiene, if you will, things that can shrink our attack surface and shrink our security posture. But that's not the only part of the story. It's not about doing that generically on infrastructure, right? An attacker knows how you harden a Windows server just like you know how to harden a Windows server. The one thing that you have an advantage over an attacker is your understanding of your applications and data and how they use the infrastructure. That's something an attacker would never know better than you would. So it is about focusing on, to use the metaphor before, understanding the families that you're protecting and how they use the house. Once you understand that, that puts you in a position to lock the appropriate rooms, monitor and react to other rooms, create a perimeter around that. It's ultimately about understanding the applications and data and how they use the infrastructure, using that to shrink your posture to create a far more effective cyber hygiene, and then to layer on top of that the ability to detect and to respond to threats, but now on a smaller attack surface with better signal to noise, better context. Now, the one challenge to everything I've just described is that most of us would concede that we don't often understand our applications and how our applications use our infrastructure. We're often in a position where we don't understand this at all. And here, we may have an opportunity that goes back to the problem statement that we started this whole discussion. And that is, if you look at the 3 problems that we laid out, a couple of these may actually hold the key to not just solving this in our new environment better, but solving this in a way that is far more effective than we've ever been able to do in the history of cybersecurity. And that's in part because as we move to more agile DevOps environments, we're starting to get more declarative of how our applications are supposed to and intended to behave. And because the infrastructure that we're building these on have very unique properties. Now, when we discuss cloud and mobility, we often talk about the fact that there are very unique properties of this infrastructure that enable us to rethink how we manage IT, how we develop applications, scale applications, really rethink things in so many innovative ways. It's interesting, however, that when we discuss security, historically, often the question asked is, how do we secure it? And the question we've been asking is there a way to leverage these unique properties to rethink how one does security? And the answer to that is very, very compelling, because in both of these cases, both on the user infrastructure side and in the data center and cloud side, we now have layers of software, abstraction layers, if you will, that are sitting in between the infrastructure and the applications and data sitting on top of it. On the virtualization side, you have a layer of software, an abstraction layer in your data centers and in your private and public clouds that sit in between the infrastructure and the applications and data. And increasingly on the end user side, with mobile devices and et cetera, end user devices, we now have layers of software that actually sit in between the same. And there is an opportunity to use that, to create, and to use the infrastructure to both bring clarity to the applications and data that's running on top of it, and how that's using the infrastructure, and then use the infrastructure itself as an enforcement mechanism to compartmentalize around applications, to create least privilege environments. In other words, to create perimeters around the home, and to use that to lock certain rooms or monitor rooms intelligently to shrink the attack surface. Now that doesn't only shrink the problem, it actually makes all of the security products that you currently have far smarter and more effective, because a secure infrastructure, if you will, can share this context with security products so that they understand the context of the applications and data. They can be inserted on the boundaries of applications, in and around the boundaries of applications and data. And they can use the infrastructure as an enforcement point to react and to respond, to more effectively respond to something that these security controls have detected without installing more agents and more boxes, to be able to have enforcement points literally everywhere. That's the idea, and we have been developing this kind of secure infrastructure, and a few examples I've just highlighted on the screen beside me. One of these is something called VMware App Defense, which is implementing this on top of the compute infrastructure. To use the analogy I described before, this is a product that uses virtual compute to understand how the family uses the home, and then to lock certain rooms or monitor and react to certain rooms. VMware NSX is a network virtualization platform that really enables this notion of microsegmentation. And again, going back to my analogy, this would be the ability to create the boundary or the perimeter around a home, a compartment around the home, as opposed to just the city or a street, to actually create a boundary around what the application uses. VMware Workspace ONE is what we've developed on the end user infrastructure side to create something that thinks about the user and the device that is accessing the application, to ensure that this really is the right user and this really is the right device with the right posture connecting in a world where we may not manage, own, or control that device directly. So it's the ability to focus on the application and the cyber hygiene around that, locking that down, is really where our home court advantage comes from. It won't be by understanding threats better or by understanding how to lock down basic infrastructure better, but by understanding our uniqueness, our applications and data, and how it uses the infrastructure, and then locking things down around that. So let me go into a few specific examples to make this more tangible. And I'll start with compute. Now, this model in the compute world is the difference between having technology that's focused on finding the bad, the malicious activity that's going on, to a model that understands what was actually supposed to be running on this machine and ensuring good. That's the difference between worrying about 75 million different bad things that can happen versus understanding the 75 good things that are supposed to happen. And that is a shift in model, but a very, very powerful paradigm shift. When you consider how a lot of attacks instantiate themselves on our workloads in our private and public clouds, you see whether it's ransomware or command and control traffic or lateral movement of an attacker in our environment, you'll often, various forms of malware, what you'll see is that the attacker or attack is manipulating things like the operating system kernel or processes running on that machine, changing how those processes interact or communicate over the network to processes on other machines that make up this application. And the idea here is to do two things: to learn what was the intended purpose and behavior of that machine for the software that you've put on it, and then to protect it by detecting and responding when what's running doesn't match that. Understanding how the family uses the home, and then detecting and responding to something that's not how my family uses that home. Now, to do this, we're simply leveraging the unique properties of virtual infrastructure, in particular these three. The first is that from a hypervisor, the basis of a virtual infrastructure, you can see both what's running, but you can also see what someone provisioned there in the first place. And that creates a very unique vantage point. The second is that you can do this kind of security without managing extra agents, and in fact, more than that, from a protected position. Now, there's a notion in security of being able to operate from what's called a separate trust domain. In other words, you can do security in two ways. You can put an agent on the machine or a box on the wire. And both of those suffer from different but equally important flaws. Putting an agent on a machine has fantastic context for a security decision. You see the application, the user, configuration, how that's changing. The problem is that you're sitting in the same trust domain as the attack surface. When an attacker attacks the application, they're now in a position to mess with the security agent. They can turn it off, they can lie to it, they can manipulate it. And that indeed happens in many of the attacks that we see. If something is stopping their progress and it's running inside the guest, the next thing they attack is that. Now, box on the wire has the opposite benefit and flaw. A box on the wire has the benefit of isolation, of operating in a separate trust domain. Just because someone has compromised the application running on your machine doesn't mean that the network security box can't observe the traffic going into and out of the machine. It's software too, it can be attacked, but it's a separate attack. The problem with it is that sitting outside the guest, it doesn't naturally understand the application, the user, the configuration. It has to reverse engineer to the best of its ability any of that and take its best guess at what those are, which often is very difficult internally where a lot of custom applications. From the hypervisor, we actually can do both. We can operate from a position in using the hypervisor monitor and kernel itself to be able to observe and protect the position of this security. So we can do this almost from a one-way mirror behind an interrogation room. Lastly is the property of automation. We now have a software-based infrastructure that is entirely automatable. So our ability to take action like quarantine a machine or re-image a machine or block network connections, or you think of it, insert full packet capture, Suddenly, those are possible anywhere. And it's simply executing a small routine on that software. So application, isolation, and automation are three properties that are tremendously powerful for security. And here's how they're actually used. When you turn on a solution like App Defense, it hooks into your inventory of all the machines through something called vCenter, and then lights up our position on all the hypervisors. And we start to catalog what's installed on those machines and what's running and the processes and how those processes are behaving. And what we're going to see are off-the-shelf software as well as custom applications. For the off-the-shelf software, we have licensed process reputational feeds and other information that allow us to map what we see back to known applications, so that this process running in memory actually is part of Microsoft Exchange version X, or this process is part of Windows 2012. For custom applications, we took a very different but unique approach, which is that we integrated back into the CI/CD pipeline. As we're moving to more agile and DevOps type development to increase the speed with which we can create and refine and develop applications, it's also moved us into a world where we're increasingly using provisioning systems and automation systems, because there's no way to do that, to get more agile and still have people manually going and installing and configuring software machine to machine. We start to turn that into automated routines using things like Puppet and Chef and vRealize Automate, using automation frameworks like Ansible, Maven, Jenkins. Well, it just so happens that these tools contain fantastic authoritative context on what the application team intended to have running on those machines. And so it provides this very unique insight when correlated with the machines themselves of what was supposed to be there and how it was supposed to behave. We augment all of this with some very innovative machine learning work. The machine learning that we've done is not focused on how looking for threats. We've done machine learning to understand good software. How does good software actually behave in the environment, behave on the network, for example? So armed with these components, we're able to translate this world, which is just today a bunch of machines, to applications divided into services, divided into machines. And we can create manifests, birth certificates, if you will, for each machine that say, this is my purpose, these are my components, and this is my intended behavior. My processes, which processes will communicate on the network to what. And we can maintain these over time. For example, the hypervisor can see anytime someone provisions something to a machine. So when that provisioning event occurs, we're in a position to say, is this just a newer version of the same software you had installed? Is this something that came through the CI/CD pipeline and they were provisioning down from the application team? Because that allows us to know the difference between just an update event versus something is fundamentally being changed here. Now, these manifests are placed in a protected area using the hypervisor itself. And in that area, we can also run a monitoring process which monitors what's running in the guest against these manifests. So we're now in a position in real time to say, the moment someone or something messes with the operating system or the functioning of that application, introduces new processes, modifies process so it starts to behave differently, it starts to communicate to different things or in different ways. Now we instantly know. It's an incredibly effective mechanism on, for example, ransomware. A system like that has no clue what the ransomware is. What it is extremely smart on is what was your software supposed to do. And at some point, the ransomware is not doing what your software was supposed to do. Then the question is, what do you do about it? And here is another advantage of using virtual infrastructure. We essentially created a library of routines that can automatically be triggered. Not just blocking and quarantining, but snapshotting, insert full packet capture, re-image the machine, a whole array of routines that can be triggered. So that the policy for something like this is not a lengthy set of rules, but rather a decision of what do we want to have happen when what's running isn't what we intended to have run for this application. This process of learning and protection is not a static thing, but a continuous thing, meaning as someone updates or changes things, the system is in a position to update the manifests appropriately. Or when we detect a change, we can start to analyze and change those manifests so that you don't have to switch between protect mode and learning mode. These are continuous things. And this is what enables security to operate at the same speed and agility as the new sort of DevOps approaches to application development. Because in the absence of it, we're in a position where security, if they were lucky enough to know what the application was supposed to do in the beginning, there's no way it knows now. Right? You can't do a 2-month security review every Tuesday. The math doesn't work out. The only way to do that is that when security can operate on the same facts as the application team and to upgrade the posture every time that updates. That's what Gartner talks about in their DevSecOps model, where security starts to move to a DevOps model just like the application teams are. And they can operate not from a waterfall approach, but a DevOps approach to security. It's a game-changing shift. Now, the framework is not just what it does to shrink the posture, but what it does to help the security controls on top. And for something like App Defense, it changes the game for products like endpoint detection and response, or container security, or MSSPs, or SIEM. For example, in each of these cases, it's about being able to share with these products the context of the application and the ability for them to use the infrastructure as an enforcement point. And we've done work in this regards on the EDR front. The first player that we've had opportunity to work with is a company called Carbon Black, doing endpoint detection and response. And they're using this to automatically refine and configure the analytics they're performing on a machine. On the container area, we now ingest this information from Kubernetes and OpenShift so that we can have a view of our applications not just in terms of machines, but also containers. And in order to have granular control in those containers, even on non-virtualized environments, we've opened the APIs so that you can plug in solutions like Aqua Security to be able to do that. On the SIEM front, the ability to surface that context so that the SIEM can see this, and the SIEM can use this as a response mechanism. And we've done this work with IBM QRadar and with Splunk, and now with RSA NetWitness. And even on the MSSP front, we've announced that we've been doing work with SecureWorks, who will be rolling out a service based on this. So each of these start to get better by being able to leverage the virtual infrastructure. This also translates to how we think about doing this for data. Right? The challenge on data is solutions like encryption can often have crippling complexity. Trying to figure out which link or what machine should really get encrypted and managing the keys for that. But that all changes when you can operate at the level of an application and say, I need this application to be encrypted. Whether it's communications between these machines or these machines at rest, and the infrastructure handles that for me as an intended state of that application. That is a much greater simplification of the problem. Now, how does this home court advantage translate to the network? And this is where VMware NSX plays a part and in introducing the notion of microsegmentation. The idea is this. In our environment, the way we had traditionally been compartmentalizing it is by putting all our web servers in one segment and app servers in another segment and database and storage in another segment. And as I described before, that really doesn't solve our problem. Because if an attacker compromises a single web server, they have freedom of movement to any of the other web servers. And of course, a web server from an application has to be able to talk to the app server of an application. So nothing stops them from moving through. It's like putting all of the kitchens in the neighborhood together. The other problem is that when you put a security control in front of one of these segments, it has to have all the policies for every possible application being represented there. So a firewall in front of the web segment ends up with 30,000 rules. And no one ever removes a rule because it's like a game of Jenga. I don't know what other applications might need this rule that might be dependent on it. It's crippling complexity. In the world of microsegmentation, you're using the virtual infrastructure to carve out all the machines that make up a given application or regulatory scope, and to create a virtual boundary without having to change the physical network or physical machines. You're using the virtual layer as sort of an overlay to make that carving. In essence, you're creating a perimeter around the home, the infrastructure that an application or a family uses. And that means that if an attacker compromises one of the other web servers or app servers or database servers, they can't simply move to the web server that's part of this application. It also means that all the security products that you're inserting in your environment can now be placed in and around the boundaries of the application so that our policies are specific, they're small, they're easy. It makes a huge, huge difference. And this is the notion of microsegmentation and why it's really been taking off in the market. Now, much like for compute, this doesn't just shrink the attack surface, this opens a world of benefits to your security products you already own, specifically endpoint and network security products that now can be inserted in and around the boundaries of an application or a regulatory scope. The final area where we can get some home court advantage from the infrastructure is on the user side of it. Now, the applications that we've been discussing include, of course, all of these components, but these applications aren't just running on the private clouds inside our data centers. They're also running in public clouds. They're also SaaS. And extending this to the user is about who is showing up at our house and how are they showing up at our house. We need to make some policy decisions about, I want to ensure that only the right people on devices that are in the right posture can connect to my most critical applications. This is why the worlds of identity and endpoint security start to converge, because we need to make these decisions in context. In a world where you don't directly manage, own, or control the device, I need to enable a user to be able to connect to the infrastructure, but it's fair to say only if that device has a certain posture, a certain hygiene, a certain integrity to it. I need to make that decision, and I need to make the decision of, is this a user that should get access, and are they who they say they are? And now we have insertion points. Now we have some places, both on the device itself, because we have a layer of software on all our end user service devices with mobile management, and in their access point, because we have networks of sort of proxy servers in the world that people can connect over the internet, but in between them and connecting to the ultimate service. And those give us very unique spots to be able to make these decisions, to ensure that it's the right user and the right device going to this critical app. And this is the work that we've done with Workspace ONE to create an environment with components like AirWatch for managing and securing user devices, and be they mobile or traditional PCs and Mac, and the identity portion and connect it together. And its focus is really on locking down that posture to create the right kind of cyber hygiene. But those insertion points can also help the whole ecosystem of security products. On that end, it's really helping identity solutions, endpoint security and device solutions, and cloud access security brokers who can plug in, who can get that context, and can use this infrastructure as an enforcement point. It's all about understanding the family, how the family uses the home, and using that to shrink the attack surface. This gives us home court advantage when it allows us to detect and respond to threats far more effectively. That's a sea change over our current environment. It's about the applications and data, using our understanding of applications and data and how it uses our infrastructure to create better hygiene, shrink the attack surface, and then to be able to layer the security controls to help us detect and respond to threats that attack that environment. That's the sea change here. And that that this notion of secure infrastructure not only shrinks the problem, but makes any of our existing investments far more effective and changes this picture from an ocean of products, each managed and controlled independently, to a much simpler picture where the infrastructure itself fulfills part of this mission, but the controls that you place on top can be far more intelligent and strategic and can really use your infrastructure in a far more intelligent way, understanding your applications and data and being able to have enforcement points anywhere. This is what we mean by going beyond securing cloud and mobility to using cloud and mobility to secure. I hope this has been a helpful session. There's been a tremendous opportunity, and there's a variety of resources on the VMware website and where you can learn more. Thank you all for joining us today.